In the courtyard of a ruined mosque at Qutb Minar complex, not far from Delhi's international airport in North India, stands a pillar of iron that has remained rust-free since it was fabricated some 1600 years ago. As a result of its remarkable state, it has fascinated historians and archaeologists, as well as those of us with scientific and technical interests, for many years. The 6-ton pillar was originally forged and erected in central India about 400 AD, but moved to its present site about 7 centuries ago. It is 7 metres high and about 40 centimetres in diameter at the base. The massive pillar was manufactured by hammering together several pieces of hot wrought iron in a process known as forge welding. The lower part is rough and pitted where it was once below ground. There is a polished region near the base because it was considered good luck if you could stand with your back to the pillar and make your hands meet behind it. Fortunately, a protective fence was erected around the pillar some years ago. An inscription commemorates the victory of King Chandra over his enemies in the 4th century AD. There is also damage believed to be from a cannon shot. There is a decorative bell at the top and a socket where a statue of Lord Garuda was once believed to have sat. So why has this 1600-year-old pillar remained rust-free? Climate in Delhi is not particularly corrosive, but ordinary iron and steel would have shown rusting over such a long-term period. We need to look at the chemical composition of the iron. The chemical composition varies, but the average surface composition is shown compared to a typical modern steel of similar carbon content. The level of impurities is low, typical of ancient wrought iron, apart from the phosphorus level. The high phosphorus content has resulted in a thin, dark grey protective layer of crystalline iron and hydrogen phosphate on the surface of the pillar, and that is the reason for its resistance to corrosion. Surely then we just need to increase the phosphorus content of steel to prevent it rusting. Unfortunately, this amount of phosphorus, over 10 times that allowed in a modern steel, has a detrimental effect on the mechanical properties. While the Delhi pillar iron has quite a high yield strength, typical of modern structural steel, the phosphorus has greatly reduced the ductility as measured by the elongation. The impact toughness would be similarly reduced. A steel with such a high phosphorus content would be far too brittle and suffer a problem that used to be known as cold shortness. A high phosphorus content doesn't matter for a pillar that just needs to sit there, but it's totally unacceptable for anything that's going to be subject to stresses, such as a bridge, building, railway, or any mechanical device. So, remarkably, the ancient Indian blacksmiths achieved the manufacture of rust-free iron 1600 years ago. Unfortunately, this was at the expense of useful mechanical properties. My name is Rob Francis, and on behalf of the Australasian Corrosion Association, thank you for watching this short presentation.